Cool. So last week, what we did was we started algebra, right? So we learned a lot of basic things in algebra. We learned what is a term, what is a coefficient, how an expression is made, etc., etc. So today we are going to take another step further down and we are going to learn a few elementary things, some things from an algebra standpoint that we all should know, right? Some terminologies we know at the hindsight, but they're not being called out specifically at times, in various, places where you've been, getting your getting your tuitions. All right. So uh, let's understand what is polynomials. You will hear this term a lot, all right? Now, an expression, as I explained last week, was an expression is a combination of an algebraic term. So let's say I say 2x, and this algebraic term has got two parts to it, the coefficient and the variable. Now, this is a term, but then this is also an expression. Now, if I say 2x plus 7, this is an expression. I can see a few more students waiting. Let me just admit all of them. Okay. Now, so this is an expression. Now, if I write 2x plus 3y plus 7, this is also an expression. But what exactly is the difference between this expression, and this expression? The first expression has just one term in it. The second expression's got two terms in it, and third expression has got three terms in it. Yes, exactly. It's got more terms. Now, the expression that has got one term in it is called monomial. The expression that has got two terms in it is called binomial. Expression that has got three terms in it is called trinomial. Can you tell me, I see a few students know here, what is the expression with four terms called? Anyone knows that? Quadrinomial. Keep writing, Darsh, keep writing, right? Quadrinomial. So if you've got four terms, so if I say 2x plus 3y plus 6z plus 7, this is quadrinomial. What about 5? Now, it is not pentanomial. It is called quintinomial. Google it, you'll come to know. It's called quintinomial. So, first term is monomial, second is binomial, third is trinomial, fourth is quadrinomial, fifth is quintinomial, and we can go on and on and on. So rather than remembering all these, I just remember one term, and I call polynomial. Can we stop chattering, please, and hear me out? You're just going to waste your time chatting, right, and not understanding it. So can I request all the students to stop chatting? I'll start calling out names, and I'm not liking it. Absolutely no chat now. If there are chat going on, probably, unfortunately, I have to, push you out of the room, right? Please. No chat, no sorry, no thank you, nothing. Absolutely nothing. Quiet. It's just distracting me. Thank you. Until the time I don't ask you to chat, please don't chat. Let's be very strict here, right? Oh, good, cool. So, combine, we call it as polynomials. So you don't have to remember, but at least the first three are important. You should know because they're quite widely used. Monomial means one term, binomial means two terms, trinomial means three terms. There's no need to remember further down. Polynomial works across. Now, if I write something like that, if I say 2x plus 3x, what type of polynomial is this? Use the chat now. Is it monomial, binomial, trinomial, quantinomial? What exactly is that? Okay, it is not binomial. It is monomial. The reason it is monomial is because they are like terms. So 2x plus 3x makes it 5x. Makes it 5x. And hence, it is a monomial. Please remember that. Cool. All right. So that's a bit of it. So polynomial in general is a collection of unlike terms. The terms are not like. So if you look at number 1, 2, 3, 4, they are not like. So obviously the first term is a monomial, so there's only one term. This one, number 2, has got two terms, they are not like, and so on and so forth. So polynomial is a collection of unlike terms. A lot of students make a mistake when they're given like terms with some operators in, and they call it as binomial, trinomial. They're all monomial. Now, let's go to the next one. I'll pop another page now. Let's understand what is a degree of an expression or a polynomial. So a polynomial comes with a term called degree. Now, if I write 2x plus 3y, I have an expression which has got two terms in it, and both the terms are unlike and they are binomial. Now, what is the power of x here? X has got power of 1. You're right. What is the power of y here? 1 again. And what is now the highest power? It's still 1. So the degree of this expression is 1 because the highest power is 1. Next, I hope everyone's able to see my whiteboard, right? If you can't, zoom in, zoom out. You'll be fine, right? Okay, next. Now I have 2x squared plus 5x plus 3. And mind you, before that, the expression that has got degree 1 is called a linear expression. So remember that whenever someone says linear, it is a degree 1 expression. Now, next one. I'm still seeing, chats going on. I have not asked any questions. I will start calling out names now, please. Right. Now, the second expression, what is the power of x? The power of x is 2. It is x raised to the power of 2. So the power of x is 2. What is the power of x in the term 5x? Sorry, I'll be clear. So power of x in the term 2x square is 2. The power of x in the term 5x is 1, correct? And this is anyway a constant term. So it does not have any power. So quick question. I just said 3 is a constant. I said 3 is a constant. When 3 is a constant, what is the power of x here? Don't raise hands, Kinetic. Write it down. If anyone's not here, if anyone's not able to see what I'm doing, I am on page number 2 of my whiteboard, and there could be zoom in, zoom out issues. A lot of you are seeing it, so it's all good. Now, exactly, 3 has a power of 3 has a variable power of 0. How can I write it down? So I can write 3 as 3x raised to the power of 0. And x raised to the power of 0 is 1. And therefore, this is 3 times 1, which is 3. So, coming back to this 3 has a power of 0. Now, what is my highest power of the second expression? It is 2. So this expression has the highest power of 2. And therefore, this is a 2-degree expression, a 2-degree expression. And therefore, it is called quadratic expression. So the degree 1 expression was a linear expression. Degree 2 expression is now a quadratic expression. I hope you're okay, right? So far, so good. Let's add another page. I'm going to the next page, guys. Page number 3. All good. Now, so we've learned the polynomials and we've learned their degrees. So a monomial can be a quadratic. So a monomial can be a quadratic. So again, all right. So if degree is not clear again, so I'll explain it quickly here. So let me write something. I said 2x squared. This is a monomial expression because there is only one term, 2x squared. But this is also a quadratic expression because it is a degree 2 expression. And what is a degree? The highest power. Highest power in an expression. So if my expression is 2x squared, what is the highest power? It's just 2 because there's only one term here. So therefore, a monomial can be a quadratic. A binomial can be a linear. For example, I said 2x plus 3y. This is a binomial. Two terms, unlike terms. And eventually this is a linear expression because the highest power is 1. All good. And also, someone pointed out here, anything which is not a linear expression is also called non-linear expression. So a quadratic is a non-linear expression. Shadow the hedgehog, please stop chattering. It's now time to call the names out, right? Stop chattering. All good. Coming back. So we understood what is a polynomial and what is a degree. Now, let's go to the next page. Let me see if I've got next page already created, I think. Yeah. All right, I'm on page number 4 now. Now let's play around with these expressions and see where we land. Cool. Now, we are going to learn something called commutative law. A commutative law is very, very simple. It says 3 plus 2 equals to 2 plus 3. Quadratic has a power 2, correct, kinetic. All right, coming back. Therefore, x plus y is y plus x. This is called the commutative law of addition. This law only works for addition. It does not work for subtraction. So 3 minus 2 is not equal to 2 minus 3. So only commutative law only works for addition. Commutative law. Now, commutative law also works for multiplication. X times y, I can write it as y times x. I can write it as xy. Algebra is lazy. They don't write multiplication. And y times x. So commutative law also works for addition. And it does not work for division. It does not work for division. So y divided by x is not equal to x divided by y. Or y over x is not equals to x over y. So commutative law only works for addition and multiplication. All right. Now we quickly learn something called the associative law. Associative law is very, very simple again. It says 3 plus 4 in a bracket plus 5 is 3 plus 4 plus 5. The BODMAS fits in perfectly here. It does not work for subtraction. This works for addition. So if I say 3 take away 4 minus 5 is not equals to 3 take away 4 minus 5. And it works for multiplication and it doesn't work for division. So 2 times 3 times 4, and if I put a bracket here, is equals to 2 times 3 times 4, if I put a bracket here. This is called the associative law, Arush. But it does not work for division. So 2 divided by 3 divided by 4 is not equals to 2 divided by bracket 3 divided by 4. That's called the associative law. So both commutative law and associative law do not work for subtraction and division. Okay, let's do a very, very simple exercise now, right? And I just need the answers, please, right? Okay. No hard stuff, please. I mean, I'm going to elementary stuff. If you are looking forward to hard stuff, I will throw that in the quiz later. I mean, I can't go harder than this. We are covering basics, right? A lot of you don't know about it. So I have to be, fair to everyone here. Okay, subtraction and division they are special. They don't fall into these laws, right? They don't work for any law. I mean, at least for these two laws, they don't. Okay, now my x is 12. I just need the answers now, all right? X is 12, Y is 6, and no calculators, please. In your select school exam, they will not give you calculators. And Z is 2. Give me X. Hear my question out first, and then once I say start solving, you solve it then. I say X divided by Y divided by Z. Go for it. Darsh, it is 4, not 3. Good. It is 4. Now let's tweak the brackets, and I say X divided by Y divided by Z. Give me the answer. So what we're doing here, this is 1. So 12 divided by 6 divided by 2. So BODMAS tells me solve this first. So 12 divided by 6 is 2, and 2 divided by 2 is 1. Cool. I hope this is clear. Easy peasy, right? I know this is not a challenge. Okay. Let's go and probably play around with a bit of a like terms, with expressions. So if I say 18ab square minus 4ac plus 2ab square minus 10ac, what's the answer? Go for it. So the like terms here are 18ab square and 2ab square. Add them up. This is a positive, that's a positive. 20ab square. Negative 4ac, negative 10ac makes it a negative 14ac. Good job. May I know what kind of expression is this? What polynomial is this? Type it down. Yes, it is a binomial. I'm not asking for nonlinear. I know it is nonlinear. But what kind of expression is this? It is binomial. It is not a quadrinomial. Because when you collect the like terms, this becomes a binomial. What if I add 5 to it? What does it become now? Trinomial. Absolutely. Good. All right. So far, so good. Let's go to the next page now. And now we are going to learn two laws of indices or powers. Two laws of powers. If you're not familiar with this term indices, call it as law of powers. Now, law of powers is if I have two algebraic terms getting multiplied with each other, their powers get added. X is nothing but x raised to the power of 1. So you can combine both of these terms into one as a one term and you add them. 1 plus 1 makes it a 2, so x squared. So what I'm trying to make a point here is that when two linear expressions get multiplied, they make a quadratic expression. So you have to think in that terms now, okay? Linear times linear is quadratic. And if I have x squared times x, power of 2 and a power of 1, they get added. So this becomes x raised to the power of 3, x cubed. This is a quadratic. This is a linear. So when a quadratic is multiplied by a linear, I get a 3-degree expression. And I call it as a cubic. So 3-degree expression is a cubic. But the law is that if you have same variable, like terms, should I say, right? No, not like terms. Unlike can go as well. But if you've got two algebraic expressions, when they get multiplied, the powers get added. Now, if I say x4 y times x square y, what would be the answer? What we're doing here is now we are just applying this power at the addition power law. So we pick up, first of all, we will identify how many pronumerals or variables I have. I've got x and I've got y. What is the power of x? It is 4 and 2. Just add them. 4 plus 2. What is the power of y in the first expression? It's 1, and the second expression is 1. 1 plus 1. So the answer is x6 y square. You add that. It's called the law of multiplication. So the first law is called the law of multiplication. Let's go to the next law, which is the law of division. And then we'll combine everything up. I hope it's clear so far to everyone, right? There are 53 kids in, and I hope it's clear to everyone, right? Law of division. I'm on page number 7 now. The law of division says that if you have a variable with a power, let's say x raised to the power of 3, divided by x raised to the power of 2. Now it's division, so you just subtract them. And you subtract left to right in division. So it becomes x raised to the power 1 or x. I can also write it like this, x raised to the power 3 over x squared. So the division is with the numerator power coming first, take away the denominator power. So this becomes x raised to the power 1 or x. So that's the law of division. Now, can you tell me x raised to the power of 2 over x raised to the power of 3? What will be the answer here? Okay, so if you don't know, cool. So let's do it, right? So Eklavya, here, we will just do the same thing. Yes, most of you are right. I will combine them into one single variable. I will pick up the numerator power 2, and I'll pick up the denominator, I'll subtract it. Always, always. Never you should do the denominator take away the numerator. So this is x raised to the power of 2 minus 3 is negative 1. So x raised to the power of negative 1. Stop spamming. Stop spamming. Cool. All right. Next one. So I hope this is clear, right? The numerator take away the denominator. X raised to the power of minus 1. Now, what will happen if I say x raised to the power of 2 and y raised to the power of 1? What will be the simplification here? I'm just reading the answers. Okay. So now what is happening here is look at the variables involved. You've got an x here, and hey, you've got a y here. So you cannot apply that law. So both the laws have a basic rule attached to it, a basic condition attached to it. The variable needs to be the same. And when I say x square, there are two parts to this, the variable and the power. This is not called the variable anymore. This is called in technical terms, this is called a base. But for your simplicity, I'm using the word variable. So the variable or the base needs to be the same. Since they are different, I cannot play around. So the answer will still be x squared over y1. I cannot touch them. I cannot play around with them. Eklavya, is it clear? Now, let's move on. If I say x square y5 over x y square, what will be the answer? Now I'm combining a lot of stuff. Okay, let's see what it is. What I'm going to do now is I'm going to collect the variables which look similar. So here x and x look similar. So I will just deal with this with the division law, just like here. So x, since they're dividing, the powers would subtract. 2 take away 1, which is 1. And I'll deal with the y's separately, which is y. 5 take away 2, which is y 3. And then I just combine them. X, y, 3. Or x raised to the power 1, y 3. Admin, stop spamming. I called you out last time as well. Please. Last warning. All right. I hope this is clear now, right? Any more spamming? You're going out. Guys, 53 of you. Anyone spamming will go out. There's something really serious going on here, right? You're not mucking around. Okay, cool. Now, what if I write 15n over 3n? Answer, please. All of you are incorrect. Hold your horses. Hold your horses. Except Siva, Kashvi, they were right. All of you are incorrect. Nirvi, you're right. Stop now. Let's understand what this is. 15 and 3 can be taken separately, which makes it 5. N and n. What is n over n? Which is n raised to the power of 1 and n raised to the power of 1. Law of division kicks in. 5 minus 5. Sorry, n raised to the power 1 minus 1 is n raised to the power 0, which is 1. So the final answer is 5 times 1, which is 5. That's the answer. I tell you what happens, most of you would know this if you would have given some time, but you were so much in rush to answer, most of you were wrong at the beginning. And this is what is going to happen in your exam. You will be roughly given 30 to 40 seconds on one question. So if you rush around, you will lose marks. So look at the question first. First 5 to 10 seconds should should be spent going over the subject, going over what's being given to you. So the answer is now 5. Okay. So technically, this question is split into 2 parts. You divide the numbers or the constants, and you just divide the algebraic terms. This was 5. This was 1. I can also say, this is such a long way to do it. Easiest way is n and n cancels, the answer is 1. So 5 times 1 is 5. All right, let's do another one. And don't start shooting answers. 5p raised to the power of 10 times 3p raised to the power of 3. Go for it. I'm just reading through. Yep, I think most of you are correct here. If anyone doesn't know, just write I don't know. I'm happy to explain. All right, what are we doing here? We are 5 times 3 is 15. P10 times P3. Law of multiplication. P10 plus 3. So the answer is 15P13. Going to the next page now. The question that I'm now going to give you will ask for a bit of a patience. And if you're rushing it out, high chances of you going wrong. So I'm writing it down and I want you to go over it, taking a deep breath and then answering it. 16, the moment I say go for it, you'll go for it. Bracket 8, 8G, this is 8G, plus 3G over 5G, take away G. Go for it. No calculators, everything by hand. If you're using calculators, you're fooling yourself. Okay, the answer's coming in. 44, 44G. 44, 44G. 45G square. 44. 176G. Okay. All right. 44G is the right answer. Now, let's understand what we've done here. The rule, always remember, your BODMAS, and in some languages, in some schools, and in textbooks, they call as BIDMAS. BIDMAS. That is the father of all the rules. This has to stay intact at any given point in time. Do whatever. Let's apply that first. The moment I see a bracket here, I will solve the bracket. I'll probably change the color. Let's take a blue, purple. Solve this. And in the numerators, now numerator and denominators can be dealt separately. So you can apply a BODMAS here independently of the BODMAS here, because they are not connected to each other for now. So let's apply the BODMAS on the top, on the numerator. 16G stays as is, times 8G plus 3G makes it as 11G, over 5G take away G is a 4G. Now this expression can be applied. We can apply the law of all the multiplication and the division rules. So how I do it is I just deal with the numbers as is. So 16 times 11 over 4, that's one side of my brain working. And the other side is the variables. I say g times g over g. So my mind splits this into two parts. The number element, I call it as the number, but they can be called as coefficients, constants, whatever you want to call, and the variable. So let's do 16 times 11 over 4. So 4 times 1 and 4 times 4. And 11 times 4 makes it a 44. And g times g over g. So if I were to really do it at ease and applying my all laws in, g times g makes it g1 plus 1 over g, which is g square over g. And then the law of division kicks in, which says g, this is 1, 2 take away 1, which is g. Or I can simply cancel one g with the other g. I cancel these two g, and I'm left with a g. So the answer is 44g. All right, that was a bit of a challenge. Let's do one more. There's no test happening. I mean, test will be given to you later on online. So we can't wait. I mean, the first test was just a pre-test, right? So we'll not do any tests here. I'll keep chattering with you here, right? This is just a test that's going on, right? Teaching and, doing practice along. Okay, test will be popped to you midweek. All right, let's do this. We've got last 6 minutes with us. -3 times xyz times -3z times -2y. Go for it. What happened? I'm not seeing those many answers so far. If you don't understand, just be honest and say, I don't understand, and I'm there to help you. All right? That's the motive of this class. Make all of you improve. Good. It's okay. If you don't understand, it's absolutely fine. It's absolutely fine. All right, let's do it. If you can't see it properly, zoom in, zoom out. Most of you can see it. All right. All right. What I'll now do is I will just take the numbers out. I know I've got a bad handwriting. Sorry about that. If I start typing, it will be time consuming. My teachers used to say it. I've got a really bad handwriting. Okay. Now, the numbers have been separated. So those of you who don't understand, take the numbers out. -3 times -3 times -2. What's the answer? For those of you who don't understood this one, what's the answer for -3 times -3 times -2? When you multiply three negative terms, the answer will always be in a negative. Always remember that. Yes, it's -18. Now, let's pick up the variable part, and I'll change the color here. I've got an x here. Do I have any more x's around? No. So I will just write an x here. I take a y. How many y's do I have? A y here and a y here. So y raised to the power of 1, y raised to the power of 1. So y, 1 plus 1 makes it 2. And z, I've got a z here and I've got a z here. So z, 1 plus 1. So that z, when We don't write in algebra, we don't write a power of 1. We just write the variable itself. It simply means power 1. So this is 2. So the final answer is negative 18 x y square z square. That's the answer. I hope this is clear to the kids who did not understand the first place. Awesome. I need to see a yes. Anyone who hasn't got it yet? All right. We will end this. I'm going to the next page and I will end this with one last question. Take a black color. Now, till the time, Satvika, you'll get your homework in the link right later. I'll send it to you parents later. Okay. Now I'm writing the last question for the day till I see you next. 2s square till the time I don't say attempt or start, don't start. Let me finish the question. And I try to write it more cleaner. Times 6t take away 3t over 6. Go for it now. Yep. I think you guys have got it. All right. Time's up, but probably I'll quickly explain how this works. Yep, 4s squared t is the right answer. This is 4s squared t. Now, how are we doing it? BODMAS, brackets first. Solve this bracket here and solve this bracket here. 6s squared plus 2s squared makes it at 8s squared. 6t minus 3t makes it 3t over 6. And finally, separate the numbers out. 8 times 3 over 6. And the powers are s square and t. And I don't see any s's around, so this will be s square. And I don't see any t's around, so t. And solve this. What would this be? 24 over 6 s square t, which is 4s square t. All good. I hope I was able to make sense today. I will share my whiteboard. I think you can pick that up, but then I will send this as a PDF to your parents and along with the quiz. Thank you very much again for the Sunday morning maths meditation. I love it. I hope you love it too. We will go from here on to tackle more complex algebraical problems. Thank you very much. Enjoy the rest of your Sunday. I'll see your lovely faces next week. Bye.